Hello everyone. I have created an application for simulating Universal Approximation Theorem. So basically Universal Approximation Theorem says that you can use a deep fully connected neural network to simulate any function. So that's what we are trying to simulate in this playground. So you can see that there are few target functions that we have created. For example, sine, you have absolute, you have Gaussian, right? So you can see that the blue line indicates the target function, whereas the orange line is the approximation which our neural network is doing for that function, right? And you can also you have the option for choosing the activation, so you can see how the activation impacts the simulation. So for example, if I choose this to ReLU, which is rectified linear unit, you can see that it's approximating it much better, right? I will go back to tan H. Now here you can also increase the number of neurons in the layer, and you can see how that kind of impacts the approximation. You also have the option to add multiple layers, right? So you can add multiple layers, right? One interesting thing I might show you. So for example, square wave discontinuous function. So this is a discontinuous function, right? So you can see because our deep neural network essentially works on differentiation. It's hard to approximate the edges, right? Because it's not differentiable at the edges. But we can increase the number of layers and see how it kind of tries to approximate the function, right? Tan H is not very good at it. Let's try with the reading. Yeah, much better, right? So it almost kind of approximates the function. We can clear the settings and it will go back to the default, right? You can also change the random seeds. Now here one parameter is the ridge regression coefficient for ridge regression. So an interesting thing about this simulation is we are not actually training a deep neural network in the background, but we are just approximating it with a linear regression model, right? Because to train a neural network with so many layers and neurons, it would be a compute intensive and time taking task. So we're not doing that, but doing an approximation for that, which is a closed form approximation. And you can read more about that in this explanation section if you are interested. So you can read about it. We'll go back to the home page. So again, you can change the seed, randomize seed, and see what impact it has on simulation, right? You can change the, you can preset some of the layers, so that option is also there, and see how the simulation changes. Yeah, so that's it for the playground. Hope you like it, and you can play around with number of layers and see the impact it has on the overall simulation. One more thing, you can see the residual errors in the bottom. So how much is the residual error from the approximation? You can also see that, right? Hope you like the simulation and you can play around with it. Thank you.